2 today. It is Delta Math again. And today we are talking about volume. And specifically about volumes of prisms and cylinders. And before this, we've been talking about area. So now we know all the different areas, like the area of a trapezoid, and the area of a rectangle, and even the area of a, what's this shape? Circle, yeah. So it's a quarter. It's the shape of a circle, okay? And what is the formula for the area of a circle? Pi r squared, pi r squared. So if I know that the area of this quarter is like 5.5 square units, and, well, that's great. That's the area of just one. Then what I want to do is maybe stack a bunch more up on top. And if I have all these same size quarters, these same size circles, and they all stack up on top of one another, my question is, yeah, so to get the volume of this, what I created here is a cylinder now. To get the volume of it, it's just the area of 1 times how many we have, okay? In this case, that would transfer to the height of this cylinder, okay? And so that is the volume, how we find the volume of anything. And I have this ream of gold paper here. And, you know, do we know the area of one rectangle? We can't find the area of one rectangle? It's 8 by 11. What's the area of this? 88, okay. And then if I stack on top of it this very thin piece of paper, and I keep stacking on the same size rectangle, then eventually we get volume, right? And so it's the 88 times the height of my stack, and that's what creates volume. So then the question becomes, now, by the way, this is the foundation of calculus. Okay. Does this paper have thickness? Yes, it does. So in calculus, we say, hey, what if it was like as skinny as a infinitely small point? All right. But this is calculus that we're doing right now. So now I want to talk about, if I have my cylinder, my stack of quarters here, and maybe it's nice and straight. Well, that I can get the volume of that by the area of the base times the height of my stack of quarters, okay? I can get that volume. What if I move my stack so it's a little bit slanty like this? Is that going to change the volume of my quarters? They're still the exact same quarters, right? Like I haven't done anything to the quarters. Okay. So that is Cavalier's principle. As long as every single layer, as long as every single shape is exactly the same size, so these are all the same size quarters, as long as every single layer is the exact same size, I can push this thing out. It can be a totally crazy shape like this, okay? Is it still going to have the same volume? Yes. This is Cavalier's principle. It states that if two solids have the same height and same cross-sectional area, they're all the same size cross-section, all the same shape. At every level, then they have the same volume. If their heights match, their volumes are going to match. Now, we're going to actually practice a little bit finding volume. So to find the volume of any prism or cylinder, we're going to use a very simple formula, area of the base times height, where B is capital B. I'm using a capital B on purpose. Capital B is the area of the base times the height. And so every time you look at a prism or a cylinder, you're going to think to yourself, area of the base times the height. So it's really important we identify the base. So on letter A here, I want to find the volume. And first question, is this a prism or a pyramid? Prism. It's a prism. Okay. And a prism has two congruent bases. What are our two congruent bases here? The pentagons. All right. So we have pentagons, and they tell us very simply here that the base area is 26. So they're going to tell us that the area of this base is 26 square units. And I just want to remind you, you're going to be allowed to use your notes on your test, so take a note. All right. And then they tell us that the height is 6. So the height of this prism is 6 units, whatever those are. I don't know. So how do we find the volume? Yeah, area of the base times height is all we need to do. The area of our base is 26 square units, and the height of our prism is 6 units. And if we multiply those together, 26 times 6 is 156. Units to what power? To the third. Yeah, unit squared times another unit makes cubic units. So our volume is 156 units cubed. Now oh, sorry, go ahead.
Volume is always cubed.
Yes, volume units are always cubed. It's a length, a width, and a height dimension. So 3 dimensions, so cubic units. So this letter B, I actually think is the hardest one. So first question, prism or pyramid?
It's a prism.
It is a prism. Okay, very important that we're talking about prisms and cylinders today. So it is a prism. And the hardest part is to be able to visually interpret your picture. So we have to say, hey, if it's a prism, then there should be 2 congruent bases. What are the 2 congruent bases here?
Wouldn't it be the base and the hypotenuse? But there's not.
There have to be 2 of them there.
It's the leg and the height, because there's a square.
What shape is the base?
It's a triangle. It's the right triangle. The right triangle is what is 2.
It's okay. It is a triangle. The base is, remember, a base is not the thing that it's sitting upon. Okay? The bases in a prism, there are always 2 congruent bases, and this is a defined term. It's not the thing that it's resting upon. It's this one. Our 2 congruent bases are the 2 triangles, okay, the top and the bottom. This prism is laying on its side instead of standing up tall. All right, do you see the bases now? Okay, it's very important that you see this triangle, this prism is laying on its side instead of on its base, okay? We have to make sure we understand that the bases are the 2 triangles. So if I want to find the volume, again, volume is area of the base times the height. Now, so I'm going to start by trying to find the area of the base. The base is what shape?
The right triangle.
It's a right triangle. What's the formula for area of a triangle? Base times height. 1/2 base times height. So in this triangle, we're going to have 1/2 our 16 times a height of 30, or vice versa, it doesn't matter. Half of 16 is 8. 8 times 30 is 240 square units. So the area of this is 240 square units. Now, here's the tricky question too. I left off part of the STEM information, the paragraph of the reading. How tall is this prism if it actually were standing up tall like it's supposed to?
It'd be 16 because it's a square.
Yeah. So this is, it's a square here. And if you imagine flipping this up so that this pink triangle was laying on the paper, it'd be standing up 16 units right here. So it's 16 units between the bases. That's what the height is, okay? So what's between the bases, how tall is it? It's 16. All right, so to find our volume here, it is going to be 240 units squared times our height of 16. And 240 times 16, 3840. Good. Units cubed. All right. So that one I think is the hardest one. You really have to flip it up in your head and imagine that it's actually sitting on its base like we expect it to be. All right, sometimes we may need to draw a picture. And please, ladies and gentlemen, please draw the picture. Please put in that little bit of effort because it does make a difference. A cylinder. What shape is a cylinder? Tall circle. Tall circle. It's a can of Pringles, yeah? So, or a soup can. So go ahead and draw one sort of smushed circle. Maybe it kind of looks like an egg. And then draw another smushed circle on top of it. Sort of. And then we're just going to connect it with two sticks, and voila! You have a cylinder. It's beautiful. Okay. All right, and we're going to label it. It says we have a diameter. Please read carefully. We have a diameter of 12 inches and a height of 4 inches.
Diameter is what goes around.
Diameter is the distance, the widest part of your circle. A diameter is the widest part of your circle. That's 12. Okay.
Oh my God,
diameter. Okay. And then we want to find the volume. So again, volume is area of the base times the height. So we need to figure out the area of our base. What shape is our base? It's a circle. What's the formula for a circle? No. Pi radius squared. Area of a circle. Pi radius squared.
64 pi.
How'd you get that?
6 squared. Or wait, no, that'd be 36.
Oh, there we go. Okay. The diameter is 12. Ladies and gentlemen, what is the radius? 6. All right. So this is going to be pi times 6 squared, radius squared, or 36 pi. And I'm just going to leave it like that because it's a beautiful, easy answer. And what's our height? 4. Okay. So then to find the volume, it's 36 pi times our height of 4. Area of the base times the height. And I can put that in my calculator pretty easily. 36 pi times 4 is 452.4. Inches cubed. They actually gave me a unit, so that's exciting. Okay. Draw the picture. Now, again, Cavalier's principle. If every layer is exactly the same size, then it can be sort of slanted just like this, and we're still going to get the same volume. It is still a cylinder. So, same idea. We need the volume, which is the area of the base times the height. Now, the question is, 7 is not the height. 7 is called the slant height because it's slanted.
Wouldn't it also technically be a hypotenuse because it's a right triangle?
Yeah, we see the little height.
7 squared minus 4 squared, and that would give you...
Oh, you are on fire today. Okay. We need the perpendicular height. 7 is a slant height. It does not work in these formulas, okay? So we need to find this perpendicular height, and as Brian said, we have a right triangle, so we can find that using the Pythagorean theorem. So leg squared plus leg squared equals our hypotenuse squared. And so I'm going to subtract the 4 squared. So 7 squared minus 4 squared. I get 33. So h squared equals 33. How do I get rid of the square? Square root it. So we get h equals radical 33. And I'm just going to leave it like that because it's a beautiful answer. And then, I need the area of my base. What shape is my base? What's the base shape? A circle. So a circle would be pi radius squared. And what's our radius? 3. Okay. So 3 squared is 9, and so I get 9 pi for my area of my base. 9 pi, and so we're going to get our volume by doing the area of the base, which was 9 pi, times radical 33. All right, we can do 9 times pi times radical 33, just like that. And we get 162.4 units cubed. Okay. So yes, still using the Pythagorean theorem every day. It never goes away. All right. All right, question so far? Area of the base times height. This is what we're doing. All right, look at E and F, and we're done. All right, volume is, once again, area of the base times height.
Please excuse the middle school track team. Thank you.
All right off the bat here, what shape is our base? A circle. All right. What's the formula for the area of a circle? Pi radius squared. And what's our radius?
6.
6, right there. All right. So radius is 6. So 6 squared is 36 pi. So the area of our base is 36 pi. Now the tricky part. We have to find our perpendicular height.
When we have to use tangent.
Tangent, yes. Once again, we're back to SOHCAHTOA. It is a 30, 60, 90 triangle, but I'm just going to use trig because it's easier. You did. It is a 30, 60, 90. All right, so we got trig here. We have an angle, and the side here is our opposite side, and the 7 would be the adjacent. So which trig function can we write? TOA. Opposite and adjacent. So TOA, tangent. Tangent of our 60-degree angle is opposite over adjacent. So H over 7. Yes, so we're going to multiply by 7. What mode should your calculator be in? Degree mode. Why? Because there's a degree symbol, 60 degrees. Okay, 7 tangent of 60 is 12.124. And so if I want to find my volume, it's area of the base, which we said was 36 pi, times our height of 12.124. But since I already have it in my calculator, I'm just going to multiply it by 36 pi. And it works beautifully. And we get a volume of 1371.2 units cubed. Questions on that one? All right, last one. Again, we're finding the volume of an oblique prism. Hi.
Hey. Yeah.
Pardon me a second. I'll be right back.
Thank you.
All right. Okay, once again, area of the base times the height. And what is our base in this problem? It's a little deceiving. It is a rectangle, but yes. It looks like a parallelogram, but that's just a three-dimensional aspect thing. But it is a rectangle, so it is just length times width or base times height. We will hold that thought. You're ahead of me, sir. The area of this base is 9 times 4, which is 36. So our base has an area of 36 units squared. And now we also have to figure out our height. Again, that perpendicular height. What is 8 called? Slant height. Yeah, because it is slanty there. So it is a slant height. Also hypotenuse.
We have a 90-degree angle, we can use cosine opposite over hypotenuse.
What is opposite over hypotenuse?
Oh, wait, sine.
Sine, yes. All right, so from our angle, our opposite side and our hypotenuse says we can use sine. So sine of our 47-degree angle is opposite over hypotenuse. And again, we're going to times by 8. So we get 8 times the sine of 47. So our height is 5.8508. And we can just plug that stuff in. What's the area of our base? 36. And our height was 5.8508. So I'm just going to take my answer and multiply by 36. Since it's already in my calculator, it makes it super easy. So 210.6 cubic units. All right. Questions from me? All right, what's the formula for the volume of a prism?
Base, or base thingy times height.
Area of the base times height. Area of the base times height.